Hi. In today's video, we are discussing about Java program matrix multiplication. Um, so I want to explain how we are going to do matrix multiplication using a Java programming. It's a simple program. I want to explain this step by step. So you can see here. First thing is we have a static main method. And here I am just declaring in integer variables like r1 equal to 2. That means two rows. That represents the two rows of a matrix. R2 means three rows of a matrix. Okay, C1 is three columns. Okay, C2 is for two columns. Now I'm going to declare two matrices. So you can see two-dimensional matrices I am going to declare here. First matrix is int of braces matrix equal to, you can see I declared uh, inside the braces 1 2 3. That is the first row of a matrix. Second row is 4 5 6. So it is how many rows? Two rows are there. How many columns? Three columns. So it is 2 by 3 matrix. So that is why you can see the first two R1 and C1, you can see two rows and three columns. We declared that. For the next matrix, you can see how many rows are there. How many rows are there? Three rows are there. First row is 7 8, second row is 9 10, third row is 11 12, right? So now what I'm doing here, you see how many columns are? Two columns are there. Okay, now you see, check if the matrix multiplication is possible. Is C1 is equal not equal to C, then matrix cannot be multiplied. Okay, written. So C1 not equal to R2. What is the C1 here? What is the C1 here? C1 is first matrix number of columns. First matrix number of columns, how many are there? 3. Is not equal to R2. R2 means it is the second matrix. Second matrix number of rows. If both are not equal, then we cannot multiply. That is the formula. But here it is equal. You can see here C1 equal to 3, R2 equal to 3. So it won't go into this condition. It will not fail. So in case if it is not equal, we are telling the program just return the control. Don't do anything. But you can see here both are equal. You can multiply these matrices. So now after multiplying, I need a result, right? I need to store the result into another matrix. So I'm going to declare third matrix, result matrix. So you can see two-dimensional matrix I declared again here, equal to new int of R1. How many rows? Number of rows equal to one row. How many columns we will get after multiplication? Two rows. We will get two rows. So here is the main logic here. First thing is we have to multiply it. So I'm going to take a first for loop. How many loops used here? 3 loops used. 2 for loops, 3 for loops. The first for loop, you see what I'm doing. For int I equal to 0, I less than R1. First row, number of rows. How many rows are there? 2. I less than R1, I plus plus. Okay, rows of matrix 1, first row. So we need to iterate for the first row of a matrix. And you can see now I'm going to take a second for loop for the matrix 2. So int j equal to 0, j less than C2, j plus plus. What is C2 here? C2 is number of columns of a second matrix. Okay, so number of columns, first number of rows of first matrix, number of rows of second matrix, second column. Okay, columns of a second matrix. How many columns are there? C2, two columns. So 1, 2, 3. So you can see first matrix is horizontal. Second matrix you can see vertical columns. Horizontal row, vertical column. First row of first horizontal row of a matrix. First vertical column of a matrix. You need to multiply both. Okay. And I'm taking a common dimension. Common dimension is for int k equal to 0, k less than c1. What is c1 here? C1 is the number of columns. How many columns? Okay, k. There are three columns, right? So k plus 1. The result I'm going to do. What I'm going to do? You see, matrix of result of ij equal to. So here we have used a plus equal to operator. That means result, how it will be like, you see, result of ij equal to result of ij plus, after that, matrix of ik star matrix 2 of kj. What is the ik here? Matrix of ik means I is for first matrix row. Okay. K is you can see k is the column. Matrix of ik, matrix first matrix row, and the number of columns. Okay, we mentioned it. And next, that means it gives the first matrix completely, right? It gives the first matrix, number of rows and number of columns. So first element of first row, first element of the column, it will give like that. So for the first matrix star, we are multiplying that second matrix. Second matrix, what is that? Matrix 2 of k comma j. So we are multiplying with the its columns. You can see k. You can see here the okay. K is what is this? K will be 0. J will be 0. So J is for columns of matrix 2, right? So first element of second matrix, first element of row of a second matrix, first element of column of a second matrix. So we are multiplying the result that way, and we'll get the result into result of ij. Okay. And after that, what we are doing, we have to print it. So the final result, as I told you, it will contain a single row, right? How many values it will contain? So R1, you can see R1 is 2 rows. 2 rows, columns are 2 rows, 2 rows, 2 columns. Okay, you can see it will contain 2 rows because R1 is number of rows are 2, number of columns are 2. So 2 rows to 2 columns, the final result. So we have to print that matrix again, because we have to take a two for loops. First for loop is number of rows, second for loop for number of columns, and I'm going to print the result. So this is how we need to analyze the code and the logic. You can see here, and that way you can actually do that. And yes, you can see the sum of the program, whether it is a prime number or not. You can check. This is also simple. I'm taking it two numbers, so one is 19 and other is 49. Okay, I'm calling this function. It is taking a parameter, and in case if number equal to 0 or 1 and return a false, don't do anything. Otherwise, I'm taking a for loop for int I equal to 2, I less than or equal to n by 2. I'm dividing it by 2, I plus plus. Okay, so we need to see here I less than or equal to n by 2. Why did we place here? Because We don't need to. A prime number is, it is divisible by itself. If any number is divisible by its any value, then it is not prime number. So the thing is, why I'm taking only half of the numbers, that would be enough, because if any number is divisible by any number of its half of its number, then we can say it is not prime. Okay, so the thing, that is why I have taken like that. And the thing is n percentile. We only need to check out the square root of n. Okay, only need to check up to the square root of n. The numbers we have to check only up to the square root of n. Okay. Okay, now for first number is 2, so we are going to check whether the number is divisible by 2 or not, first thing, as per the for loop. So 2, what is the number? 19, right? 19 percentile 2. What is the percentile? Percentile is remainder, I think. Okay, 2 nines are 18. I'll get a reminder 1. So what is reminder equal to 0? Not a prime number. You see, but thing is, 2, and is it divisible by 3? Then see, so 4, 19 is divisible by 4. You check incrementing the number. Okay, it is not divisible by 2, it is not divisible by 3, it is not divisible by 4. 5, is it divisible by 5? No. Okay, 6, is it divisible by 6? No. Because so what is n by 2 here? N by 2 will give 2 8s are 2 9s are 18. So we'll take up to 9 value. We'll check only 9 value. And sixth value, what is sixth value here? Sixth 6 percentile. 19 divisible by 6. No, 6 3s are 18. No, it's not possible. 7, 19 by 7. 7 2s are 14. 21, 7 3s. No, it's not divisible. 8, 8 2s, 16. 24. No, it's not divisible. So next, 9. 9 2s are 18. No, it's not divisible. So 19 is a prime number. It's not divisible. It will come out from the, it won't match there. So then it will exit the for loop, and it will come to the true, return true. So 19 is a prime number. Same is applied for the 49. Okay. But 7 7s are 49, right? So second value is not a prime number. You can see 7